This is 12-6 segment relationships in circles. Pause the video and draw out the chord product theorem, which is on the left, and the conclusion that we can, that is a result of the hypothesis. So draw this and write this out, and then hit play again to continue. Keep in mind that chords are segments that go from one end of the circle to the other. So for instance, we have chord AB and we have chord CD. They are not meeting in the center. That E is not the center of the circle. And also, the point of this is so that we can find a chord measurement. So maybe we'll have an unknown in here, an X, and we'll have to find the chord measurement. So we'll look at an example now. The chord product theorem says that PQ times QR is equal to SQ times QT. So we're going to use that information to solve for X. Let's write that out. 6 times 4 is equal to X times 8, which is 8X. So now I just algebraically solve for X. So 24 equals 8X, divide both sides by 8, and I get X equals 3. If X equals 3, we can now find the length of each chord. We already knew the length of PR. PR is 10 because of the 6 and 4, and ST is 8 plus 3, which is 11. Here's another example. Try to find the value X in the length of each chord for this problem. Pause the video, and then when you're ready for the answer, hit play to see if you're correct. So I did 6 times 5 equals 8 times X. I solved algebraically. I got 30 equals 8X, divide both sides by 8. X was 3.75. Then from there I plugged my value in the X spot. I added my 8 and my 3.75 to get the length of chord CD, which is 11.75, and the length of AB was 6 plus 5, which is 11. The next theorem is called secant product theorem. So remember, secants are extensions of chords. They're chords that continue through the circle, like secant AE, for instance, in the picture above. So pause this video, copy down the secant product theorem, both the picture and the conclusion. This theorem is saying that if you take the total secant AE and multiply it by the exterior part of that secant BE, so total times exterior is equal to total of the other secant, CE, times the exterior piece, DE. So let's apply that to our example down below. It says find X in the length of each secant. So I take the total of RT, which would be 10 because 6 plus 4 gets us our total length of RT, 10. So I have 10 times the exterior. The exterior is 4 equals total of this, which would be 5 plus X. That's a binomial, so I'm putting that in parentheses, 5 plus X times the exterior piece, which is 5. And so that's going to be distributive property right there. So I solve this algebraically. 40 equals 5 times 5 is 25, plus 5 times X is 5X. Solve this equation. We get 15 equals 5X, and X equals 3. And now we can find the length of each segment, so each secant. So this secant we know is 10. RT is 10. Segment RT. And then segment RQ, is equal to 5 plus 3, 8. Try this problem. Pause the video, and then when you're ready for the answer, hit play again. Okay, so I took my total of JG, secant JG, which was 13 plus Z, and I multiplied it by the exterior 13. So 13 plus z times 13. Remember, that's going to be distributive property. Equals the total of LG is 39 times the exterior of 9. So I got 169 plus 13z equals 351. I solved that algebraically to get z equals 14. I plug my 14 back in to get the length of JG, which is 27, and then the length of secant LG, we already knew without doing anything here, would be 30 plus 9 is 39. This is the secant tangent product theorem. Notice that we have secant AC with an exterior piece BC, and then we have tangent CD. Remember, tangent will only hit the circle at one point. So we get secant AC and tangent CD. Copy down the picture and the conclusion into your notes for the secant tangent product theorem. And pause this video when you're ready. Pause it and then hit play when you're ready to continue. Okay, in the example, we're told to find the value of x. So using the theorem, which says take the whole secant, which would be 9, 5 plus 4 is 9, multiply it by the exterior piece, which is right there, that's 4. That equals the tangent, PQ, which is our value of x squared. So the whole total secant times the exterior piece equals the tangent squared. So now I'm going to solve that. We get 36 equals x squared. To get rid of the x squared, we'd square root both sides. We end up with 6 equals x. Try this problem. You're looking to find the value of y. Pause the video and when you're ready for the answer and the work, hit play. So I took my whole times my exterior. My whole would be 7 plus y, the whole piece, times the exterior piece of 7, that DE length of 7, equals the tangent squared, which would be 10 squared. So I got 49 plus 7y equals 100. Subtracted 49 from both sides, so 7y equals 51. Divide both sides by 7, and I get y is about 7.3.